be talking about how to prove triangles are congruent. And this is our first day looking at this. So what we're going to look at first is the process to follow when you complete these triangle congruence proofs. And I have a 4-step process. And if you followed this process, these proofs should become much easier for you to complete. So the first step is to label your picture with swoopies and dashes. We've been doing this for 2 days, so you should be more comfortable doing this. You use any given information, and then anything else you can see, like your vertical angles or your shared sides. Number 2, you write down your given statement on your proof. You always start your proof with a given statement. Number 3, you write down 3 congruent statements, either angles and sides, and you look at your given to see if some are already there, and you use your picture to write the rest. And you're going to see how this works at the very end. And then lastly, you complete the proof with a triangle congruent statement and your reason, either your side, 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 angle, or angle, angle, side. And we've been practicing recognizing these, so we can get those from the picture. That should come pretty easily to you by now. Before we practice any proofs, we have to look over the reasons and statements that we can write down from the picture. So we know how to label our picture, but we need to now take that labeling from the picture and put it in proof form. So the first one is, if we look at this, this is a reason that you can just look at the picture and you can draw on it, is the reflexive property of congruence. If you look at this picture, these 2 triangles share a side. So we can put a dash right there, okay? We can put a dash right there. So we can say that MO is congruent to MO. And that's our reflexive property of congruence. And that's how we take our symbols from our picture and write it into a proof. Let's look at another one. This is your vertical angles. We can just look at the picture and automatically know, wait a second, I see vertical angles. I can put in my swoopies right here. So now we're going to take that information and write it into the proof. So we have to say angle ABD is congruent to angle EVC, and that's because of the vertical angles congruence theorem. So those are the 2 things that you're allowed to draw in just by looking, your reflexive and your vertical angles. Next up, what we're going to look at is if I give you a certain amount of information, okay? And you only can draw this in if I give you that information. You can't draw it in, you can't just assume, only if I give you that information. So the first thing you're going to do is actually write down your given statement. I'm going to write down N is the midpoint of line segment PO. And the reason for writing that down is that it's given. Next, we're going to draw this. We're going to draw our symbols on our picture. That means if N is the midpoint, it breaks PO into 2 equal or congruent parts. So we can do our 2 dashes. And the way we write that down in a proof is that PN is congruent to NO. And the reason for writing that down is our definition of midpoint. All right, let's look at another one. This one, I give you the information that MN bisects PO. So let's write that down. Line segment MN bisects line segment PO. And the reason for that is that it's given. Now let's mark this on our picture. A bisector does the same thing that a midpoint does. It cuts that segment into 2 equal parts. And MN is cutting PO into 2 equal or congruent parts. So we can write this down as PN is congruent to NO. And this time, since it's a bisector and we're bisecting a segment, we're going to call this the definition of a segment bisector. All right, let's go to the next one. This one, we have another bisector, but it's a little different because MN bisects angle PMO. So now we're bisecting an angle. So let's write this statement down first. MN bisects angle PMO. And the reason for writing that down is given. Now let's draw this on our picture. So MN is our bisector, but it's bisecting PMO, which is this angle up here. So it bisects it into two congruent angles. Those two pieces up there, two congruent angles. So we can say that angle PMN is congruent to angle OMN. And this one is called definition of angle bisector because we're bisecting an angle. All right, let's go to the next one. This one is if I give you the information, you have an isosceles triangle PMO with base PO. So an isosceles triangle, when we think of an isosceles triangle, I can assume, or I know, that these two sides are congruent because an isosceles triangle gives us two congruent sides. So let's write down that statement, isosceles triangle PMO with base PO, and that's given. So if we have an isosceles triangle, we know that those two sides are congruent. So we can write down that PM is congruent to MO. And that's the definition of isosceles triangle. That's our definition of isosceles triangle, that those two sides are going to be congruent if your base is PO. This next one, we're dealing with parallel lines. And it tells us that PM is parallel with ON. And whenever we have parallel lines, I like you guys to highlight those parallel lines. So PM is parallel to ON. And once you've highlighted those two lines, you have to connect them with the transversal, that one right there. Okay? So parallel lines give us congruent angles, okay? But these are called alternate interior angles. So parallel lines are going to give us alternate interior angles. So let's write this given statement down. PM is parallel with ON, and that's our given statement. And we can write down that angle PMO is congruent to angle NOM because of the alternate interior angles theorem. This one we haven't seen before, it's brand new, but whenever we have parallel lines, it gives us alternate interior angles that are congruent. So that's a new one. Now our next one deals with perpendicular lines. And this one, we have to do more than one step. Okay, so first of all, let's write this down. MN is perpendicular with PO, and that's our given. Well, perpendicular lines give us right angles. So MN and PO are right here. And if those are perpendicular, then we have two right angles right here. Okay, so the first step that we need to do for this is we have to state the two right angles. So we have to say angle PNM and angle ONM are right angles. Okay, and this is the definition of perpendicular lines. And then once we state that they're right angles, we can say that angle PNM is congruent to angle ONM because of the definition, or sorry, the right angles congruency theorem. The right angles congruency theorem. All right, so let's take a look at some proofs using all of these different statements and reasons. Okay, so the first thing we're going to do is we're going to write our statement down, the given statement, the very one at the top. So we're going to write down that triangle DEG is isosceles with base EG. We're also going to do the second one. That line segment DF is a segment bisector of EG. So we're going to write those two down first. Okay, and the reason for that is given. The next thing we're going to do is we are going to mark our triangle. Okay, so the first one, DEG, is isosceles with base EG. So let's mark that. That means that these two sides are congruent. If those two sides are congruent, let's write that down in our proof. We can say that ED is congruent to GD because the definition of isosceles triangle. The next one, let's look at our next given. Our next given says that DF is a segment bisector of EG. So DF is a segment bisector of EG. So EG is going to be bisected into two equal parts. And this is our second set of dashes, so we have to put 2 dashes for each. So we can write down that EF is congruent to FG because of the definition of segment bisector. And now our very last one is we can actually look at the picture and they share a side. So we know that this is congruent to itself, and we're going to do the 3 dash marks. So we can say that DF is congruent to DF because of the reflexive property of congruence. Okay. And now I like to count. If we have 3 congruency statements, we are ready to write down our proof. And our proof is triangle DEF is congruent to triangle DGF, and this is going to be a side, side, side. Okay, so that's our first proof. Let's look at one more of those. Let's look at another one. Okay, so this one deals with perpendicular lines. Okay, so let's write down our given statements. We can say that DR is perpendicular to AG, and that RA is congruent to RG. And if you notice, okay, that's a given, they've already given us a congruency statement. So that's actually our first congruency statement. It's already written down. All we have to do is label it on the picture. So that's a given. So we actually only need to find 2 more congruency statements. So let's look at these perpendicular lines. Perpendicular lines give us right angles. They give us right angles. Right there, we have 2 right angles. So what we have to do is we have to do this in 2 steps. We have to state that ARD and angle GRD are right angles because of the definition of perpendicular lines. Once we've stated that, we can write down that angle ARD is congruent to angle GRD because of the right angles congruency theorem. And the last one we actually can find from just looking at the picture. They share a side. So we can say that dr is congruent to dr because of the reflexive property of congruence. And we already have one congruency statement at the top. We have a second one right here, and a third one right here. Okay, so we're ready to prove. So we can write that down, that triangle DRA is congruent to triangle DRG. And let's look at this. We have one side, one angle, and one side. So this is going to be a side angle side for that one. All right, I have one more proof to show you. One last one. Okay, first thing we're going to do is we're going to write down our given. Q is the midpoint of MP. And Q is also the midpoint. So we have two midpoints here of ON. And we can write that down because it is given. So let's do these one at a time. So the first one, Q is the midpoint of MP. That means that these two pieces are going to be congruent to each other. So we can say that MQ is congruent to QP because of the definition of midpoint. So that was our first given. Let's look at our second given. Our second given says that Q is a midpoint of ON. So that means these two pieces are congruent to each other. So we can say OQ is congruent to QN. And once again, we have definition of midpoint because we had two midpoints. And our last one is we can look at the picture and we have vertical angles right here. We have vertical angles. So we can write down that angle MQN is congruent to PQO. And that's our vertical angles congruence theorem. And now that we have three congruency statements, we're ready to prove. So we can say triangle MQN is congruent to triangle OQP. And if we look at this, we have a side angle side. So this is side angle side.